In this video, what we're going to do is we're going to explore how to find the probability of some simple events. And just to start, I'll define a simple event as an event that has only one part to it. So in this case here, where we're trying to find what is the probability of rolling a 5 on a standard die, what makes this a simple event is the fact that we're only rolling the die one time. Another example of a simple event would be flipping a coin one time or spinning a spinner one time. When we start rolling dice 3 times in a row or drawing 4 cards from a deck of cards, those get into what we're going to refer to later on as compound events. But for this case here, let's answer the question, what's the probability of rolling a 5 on a standard die? And to help us visualize this better, what I've done is I've created a net for a standard 6-sided die, and a net's just what it looks like when it's been unfolded. So I'll just write in the numbers here. For those of you who are unfamiliar, all 6-sided die are kind of put together the same way, where you have the 1 and the 6 are on opposite sides, the 2 and the 5 are on opposite sides, and the 3 and the 4 are on opposite sides. And what makes these opposite sides is if you were to fold this together, you can actually see that the 1 and the 6 kind of end up being maybe top and bottom, the 2 and the 5 front and back, and the 3 and the 4 the sides. So we can use this to help us with some of our probability statements here. So the first one is, what is the probability? So remember, just P, and our event is rolling the die, and the outcome we're looking for is a 5. So if you remember, it's the total number of outcomes and the number of favorable outcomes. So let's take a look at this here. Our net shows us that we have 1, 2, 3, 4, 5, 6 total outcomes, and only one of those results in a 5. So 1 out of 6 is the probability of rolling a 5. Let's look at something different. Let's look at the probability of getting an even number. And so in this case here, we have to look at numbers a little bit more carefully. Once again, we still have 6 total outcomes, and those are the 6 listed on the side. And we have 1, 2, and 3 of those numbers are even. So the probability of rolling an even number is 3 out of 6, or 1 out of 2. Let's look at another one here. Let's look at the probability of getting a number that is, let's say it's greater than 2. Greater than 2. And so same thing here, we'll take a look, and we've got 6 total outcomes. So how many of those outcomes result in a value greater than 2? Well, here we have, that's 3 is greater than 2, 2 is not, 4 is, 6 is, and 5 is. So we've got 1, 2, 3, 4 values that are greater than 6, or sorry, 4 values that are greater than 2. So that leads us to 4 out of 6, or 2 out of 3. The second part of this is going to focus on the spinner that we see shown here on the right, and we're going to explore some of the more complicated probability situations for simple events. This is asking us, what is the probability of the spinner landing on a blue space or a red space? And so in this case here, we have 2 possible favorable outcomes. So let's make a probability statement for that. So to start with here, what we have is the probability of red or blue. So a good way to think about this is, if this was a game, we would win if the spinner landed on a red space or a blue space. So let's just quickly take a look at the spinner here to see what we can figure out. The spinner has 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes. Right? There's 8 slices to the spinner, or 8 different spaces, and I've numbered those 1 through 8. So of those, how many of them are red? Well, we have 1, 2 that are red, and how many are blue? We've got 1, 2, 3 that are blue. So actually, I'm just going to make a note of that. I've got 2 red spaces, I've got 3 blue spaces, and since we're talking about colors, I've got 3 green spaces. So once again, I have a total of 8 possible outcomes. How many of those match these criteria, being red spaces or blue spaces? Well, 5 of them do. So the probability of landing on a red or a blue space is 5 out of 8. Let's look at a different one here. The probability of landing on a red or an odd space. So same thing again, but this time we're going to throw in numbers and colors. So what we're going to do is we're going to look at each single one of these, and I'll just put a check mark in the space if it matches one of those criteria. Remember, in order to win, the spinner has to stop on a red space or an odd numbered space. So let's look at each of our spaces. Space number 1 is a winning space because it is an odd number. Space number 2 is a favorable space because it's red. Space number 3 is a favorable space because it's odd. Space number 4 is favorable because it's red. Space number 5 is favorable because it's odd. Space number 6 is not red, nor is it odd, so it's not a favorable space. Space 7 is favorable, and space 8 is not. So in total, when we sum these up, once again, we still have 8 spaces altogether, but 1, 2, 3, 4, 5, 6 of those are favorable. So the probability of landing on a red or an odd space is 6 out of 8 or 3 out of 4. Now there's another way we can think of this, and this brings up a very important pair of words in probability, and that is the word and compared to the word or. So in this case here, what we're going to find out is what's the probability of landing on a red space and an odd space. So in this case here, it's a little bit different because in order for us to win, both of these have to be met. So let's just maybe make a note of that, right? In this case here, both conditions need to be met. Whereas in the previous one, really what we were saying is either condition. So let's explore this. The easiest way to do this really is to focus on the spaces that are red because those are easy to see. And let's see how many of those red spaces are also odd spaces. So this space is red, but it does not have an odd number with it, so it is not a favorable outcome. And this red space here is also not odd, so it is not a favorable outcome. And likewise, all of these other spaces, none of them are red, so they are not favorable outcomes either. So when we go around the entire spinner, what we find is that of those 8 total outcomes, none of them are favorable. None of them would allow us to meet both of those conditions. So the probability of landing on a red and an odd space is 0%. So the key thing to remember for this point here is you're going to see some situations with the word or in them, and that basically is implying that either of those 2 conditions has to be met in order for the space to be favorable. And sometimes you will encounter the word and, which is telling us that both of those conditions need to be met in order for it to be a favorable outcome.